This video is on calculating vectors, which is part of the P5 specification. So, in terms of the specification, the things that you need to know about vectors are, first of all, you need to know the difference between scalars and vector quantities, and how vectors can be added together, both when they're parallel and when they're non-parallel, or at 90 degrees to each other. Moving on, you then need to understand about Suvat equations, or the equations of constant acceleration, which is a separate video. So, objectives then for vectors is you need to identify scalar and vector quantities, determine the sum of parallel vectors, and apply trigonometry and Pythagoras to perpendicular vectors. And in the overall sort of scheme of P5, it is lesson 3. So, first thing, if you think about the motion of two vehicles, okay, relative to each other, and what we mean by relative is the motion compared to each other. So we've got a red car that's going at 65 miles per hour, and we've got a blue car going at 70 miles per hour. Now, if these two cars are travelling in the same direction, as shown on the arrows, because velocity is a vector quantity, which means it has direction, and direction is important, if I was to compare the relative speed of car A to car B and vice versa, then what would happen is that from the red car's perspective, the blue car would be going 5 miles per hour faster in that positive direction. From the blue car's perspective, if you imagine the blue car, the person sitting in the blue car, it looks like the red car is going backwards, because obviously he's overtaking him. And so from the blue car's perspective, the red car is actually going minus 5 miles per hour, because it appears to be going in the opposite direction. Obviously they are both travelling in the same direction, but relative to each other, it appears that the red car is going backwards. If we were to make the cars go in the opposite direction to each other, so now the blue car is travelling at 70 miles per hour in this direction, it'd be very different. So if we have this as the positive direction and that's the negative direction, from the red car's perspective, the blue car would be going at minus, because it's travelling in the minus direction, 135 miles per hour. So when you pass a car on the motorway, they don't appear to be going at 70. When they actually come close to you, they appear to be going a lot faster than that. And again, from the blue car's perspective, the red car would be going plus 135 miles per hour. So the direction, it doesn't matter which way we define the positive or negative direction, as long as we're clear about which one we're saying is which. So this idea of relative motion is important with vectors. So when you have, if I was to represent these as arrows, you could add or subtract the vectors to give you the vector sum. So we'll come back to that in a second. So velocity is just one example of vectors. There are a whole load of others. So scalar quantities are anything that have magnitude only. So what we mean by magnitude is just a size, it's just a number. So like, if I've got 4 apples, it doesn't matter whether my apples are up, down, sideways, backwards, whatever direction, the apples don't have a direction. But I could have 4 apples, and I could, add those to 3 more apples, and I'd have 6, and it wouldn't make any difference as to any kind of direction. So a scalar quantity is something that only has magnitude. Vectors have magnitude and direction, so the direction has to be taken into account. So distance is a scalar quantity, but displacement is the vector form of distance, so it's distance in a given direction. Mass is an important one, obviously in kilograms. Velocity is the vector equivalent of speed, so speed doesn't have a direction, but velocity does. Energy is a scalar, acceleration is a vector. Speed, we've mentioned, is the scalar form of velocity. Force and acceleration are obviously very closely linked by F equals ma. So they're both vectors. Weight is a type of force, remember, so it's just the force due to gravity. So that is again a vector quantity, always acts downwards. Power is a scalar. Time is a scalar. Time doesn't have a direction. And momentum is a vector. So you've got a whole range of examples of scalar and vector quantities there that you should know. So if we think about adding vectors together, then if I have I'm adding 2 parallel vectors. So imagine I start here, and I'm going to walk 4 meters north. I apologise for my not being a perfect straight line, but I walk 4 meters north. And then at this point, I then decide to walk exactly 3 meters south, the total distance that I've travelled, turn that into a 3, okay, the total distance that I've travelled is going to be 7 metres, so I've gone 4 and then 3, but my displacement, the actual distance, the distance that I've moved from my starting point, is only going to be 1 metre. So parallel vectors, are very straightforward, and you just add them and take them away. There's nothing complex about that at all. When you've got vectors that are perpendicular to each other, it becomes a little bit more challenging. So if I've walked 4 meters north, but then I walk 3 meters east, so I've got 3 and 4, I've then got to work out, well, what is my total distance is still 7 meters. That's not changed. But my displacement now is very different, because it's going to be this distance here, okay? And I've got to have a method of working it out. Now, you may recognise that that is 5. If you think about your maths lessons and you've done Pythagoras' theorem, you should recognise a 3, 4, 5 triangle, and so recognise that that is 5 meters. But we'll look at where that number comes from in a second. So, in order to sort of solve these problems with a vector, we have to think about, we have to use trigonometry. So any vector that is at an angle, like in the one shown in this diagram, so I've got a vector of 20 meters, so it's a displacement, and it's at an angle of 30 degrees. So what I have to do is I have to resolve it into the vertical component and the horizontal component. So think of it as how far north, the vertical component, this person has walked, okay, compared to how far east they've gone. So the vertical component would be this arrow here. So you have to know trigonometry to do this. So you've got to think that we've got the angle here, so this is going to be our opposite. This is obviously the hypotenuse, because it's directly opposite the 90 degrees, and that means this line here would be our adjacent, okay? So when you're working out the vertical component, if you have these 3 things, what I would always like you to write is I would always like you to set out your working like this. So write theta, write down opposite, adjacent, and hypo. So you're basically doing the 4 steps. So you're writing down what the question tells you. So I know I have an angle of 30 degrees. The opposite, in this case, the vertical component, is what I'm asked to work out, so I put a question mark. At the moment I don't have the adjacent, so I'm going to ignore that and put a cross there, and then I know the hypotenuse, which is 20 degrees. So then I have to use SOHCAHTOA, and the equations of SOHCAHTOA for trigonometry are given up here, so sine, cos and tan. And what I do is I look for the one that doesn't have adjacent, so both cos and tan both have adjacent in there, so clearly I'm not going to use that one, so I have to use sine. So what I'm then going to do is I rearrange that equation to give me opposite. So the opposite is going to be equal to the hypotenuse multiplied by sine theta. And then so then I put my numbers in, so it's going to be 20 times the sine of 30 degrees. That will give me my opposite, okay? Which will give me 10 meters when I do that. If I'm then working out the horizontal component, I use the same approach, but now I'm working out the adjacent as opposed to the opposite, and so I would use cos, and so I would do very similar, but I would do 20, if I was doing the horizontal component, I'd do 20 cos 30, which would give me, it's just cropped off the bottom of the video, but it would give me 17.3 meters, which you can see is further than the vertical. Now, the other thing that we can do is go opposite. So when we have the vertical and the horizontal component of a resultant vector at an angle, we can obviously work out what the resultant is. And this is much simpler. We just use Pythagoras' theorem. And Pythagoras' theorem states that the square of the hypotenuse, so the square of r, so r squared, is equal to the sum, which means added together, of the square, so in this case 8 squared, and 5 squared of the other 2 sides. So I'll say that again. So Pythagoras' theorem is that the square of the hypotenuse is equal to the sum of the squares of the other two sides. So whatever 8 squared plus 5 squared is, that will be equal to r squared. So in this case that's going to be r squared is 89, and then we have to square root that to give us our value for r, which is 9.4. So we use Pythagoras' theorem to do this. If I want to work out theta, if I know all three sides, I can use pretty much any trigonometry equation I wish, but because in the question we've been given the adjacent and the opposite, just to keep it simple, we'd use tan, and then so tan theta is the adjacent divided by the opposite. Just in terms of picturing which one the opposite would be, you could imagine this vertical component could also be drawn here. So that's why that is the opposite, because the angle is there, so this one becomes the opposite. So it would be 8 divided by 5, which would give you an angle of theta of 58. Just remember that tan theta won't be equal to 58, so on your calculator you have to do tan to the -1, and then whatever the value of tan theta is, which is obviously going to be 8 divided by 5, that will give you your answer for theta, which obviously is 58. So make sure that you can do these 3 skills, so adding vectors that are parallel, resolving vectors, so when you've been given a resultant, working out the vertical and horizontal components separately using trigonometry, and then lastly using the horizontal and vertical components to work the resultant back out. And you're going to get lots of chance to practice this in lessons, but it's important that you watch this video again if you don't understand any of the skills we've just talked about.